A very good afternoon to all of you. I am Ella, welcoming you all to the Solar Efficiency Redefined Trackers in Focus webinar. Before we proceed further, I would like to thank our panel members for their immense support to organize this event and to our crusaders tonight, New Energy Renewables. Their commitment to promoting sustainable energy solutions is truly commendable. May I now invite Mr. Satinder Agarwal, MD New Energy Renewable, to give the presentation for his company. Over to you, sir.
Yep. Thank you, Ahla, for the introduction. I am the Managing Director of New Energy Renewables Private Limited. I would give you a quick upside about the company and then get on to the presentation. We are a company that's in operation since 1993. And the last 32 years, we have done various developments. One of the latest ones is the system of single axis and the double axis trackers for solar plants. I would give a presentation on this in a short time as soon as possible. Let's try and get this through. Yeah. I would like to know if everybody can see my screen. I just need a confirmation. One moment. So are we good to go? Is the screen visible to everyone?
Yes, sir.
Yeah, okay. So this will be a quick presentation on the single axis trackers and the in principle solar tracking technologies that New Energy is doing. We are a company based in India, and currently our manufacturing capacity is about 2 gigawatts per annum, and we are under the expansion mode to get to the 10 gigawatt per annum mode in the next 18 months. The manufacturing of these trackers is largely in India to the extent of more than 75%, and balance comes from either our global collaboration partners, which is SAT Control from Europe, and there are certain other suppliers from abroad whom we use the equipments from. We are providing both the single axis as well as the dual axis trackers, and we are adaptable to any requirements that any developer may have. I have given you that this is a brief about the company since 1993, where we were manufacturing energy efficiency equipment, and we have grown from there in various businesses as the times have gone by. We are also into developing the EV charging infrastructure. We provide rooftop solar on OPEX. We have done EPCs in the past to the extent of almost 650 megawatts, and currently we are providing the single axis trackers in collaboration with SAT Controls DO Slovenia. SAT Control is again a company that has more than 20 years of experience in solar tracking technology, and they are our current partners for on a global scale for all the tracking technologies that we offer to all our clients. SAT Control has a manufacturing facility where they manufacture the electronics, the tracker positioners, the junction boxes, and the Sigma servers, the monitoring software, and the systems. And they are providing these to all our plants, and the mechanical parts are now manufactured in India. We are all aware of the reason why the tracker boosts the power because the tracker is tracking the sun. A typical fixed tilt has a very typical inverted bell curve, as you see in the dark blue. And the tracker, because it follows the sun, gives you a broad shoulder on the generation, which is what actually is the boosting power from a tracker system. There are various types of module mounting systems. We will focus ourselves to the tracking systems here. So Visa New Energy, we offer various trackers. One is a conventional tracker, which is a tracker where the modules are fitted flat and they are operating east to west. There is an innovation in the tracker where we are fitting the modules in a tilted format on the tracker, which gives you a boost in generation as well as there are various other advantages. And the last but not the least is, of course, the dual axis trackers, which has specified uses. In terms of generation, the regular tracker may generate or give you about 15 to 18% boost in the generation as compared to the fixed tilt. As compared to that, the innovation that we have created in the tracker gives you up to from 24 to 30%, and the dual axis tracker can give you from 34 to 38%. Now, depending on the type of requirements, depending on the type of application, depending on the size and the developer needs, the various trackers are provided and they are adapted. In on the single axis trackers, there, like I said, there are two models. One, if you see the picture on the left, these are the modules which are fitted flat on the tracker, which is a conventional tracker where most of the trackers are available on these ones. On the right hand side, you will see the tracker where the modules are tilted to a particular angle towards the south and the northern hemisphere. Now, this gives you a big boost of generation by from 15 to 18% to 24 to 30%. And this we have experienced on all these sites that we have done so far. There are advantages of tilted modules on the tracker. One of them being that there is a better wind profile, as you'll see that there is a clear path for the wind to flow between the modules and from east to west also. There are clear paths everywhere, which results in very, very low mechanical stresses. There is a much better heat dissipation because the heat is dissipated from the surface of the module as well as from the back, which results in lower operating temperatures. And this also means that because the power coefficient is negative for the modules, it gives you a boost of generation to the extent of almost 1.5% because of the change in temperature of the surface of the module. Last but not the least, because the modules are tilted, we get a higher energy from the sun, and this also boosts further because of the tracking systems. On the dual axis models, we have two models. One on the right hand side, if you see, this is a true dual axis tracker which gives you east to west tilt of about 100 degrees and north to south an additional 75 degrees depending on the type of the month and the climate. The one on the left is again an innovation on the dual axis tracker, which is sometimes done to reduce the cost to make it very, very economical, where the east to west remains -50 to +50, but the north south is restricted to 0 from 0 to 12. This may not be the most efficient way, but this does drop the prices to a large extent, and the generation increase as compared to the fixed tilt on the tilted side is 30 to 35% over fixed tilt, and the true dual axis tracker, as we call, can give you about 36 to 40%. So, New Energy provides solutions on the solar tracking systems on all the types of models as may be required. On the design part, I would like to show a few highlights. One of them is that like I explained, the tilted modules on the tracker, they give you a better wind profile. The highest generation in India that we achieved, which is in itself a record of sorts, is about 8.9 units to a kilowatt peak per day, which is much greater than we have achieved almost 30% of the generation as compared to the increase over fixed tilt. The power consumption, there'll be a video that I'll play next. You'll find that because there is no hindrance to the movement, it is the only technology with oscillating tubes and the tubes are floating. There is no rubber, there is no nylon, there are no bushes, there are no non-metal bearings, because of which the consumption is extraordinarily low. We are typically consuming about zero point 0.4 to zero point 0.5 units per megawatt peak per day, which you can compare to a 10 watt or a 12-watt LED bulb, which is an extremely low consumption for a megawatt of trackers. Because there is no metal contact part, there is no maintenance. The design is very simple, and there is a fantastic ease of installation because we pre-assemble all the parts and we send it to the sites, as against maybe 100 parts or 150 parts that are normally associated with a tracker which are assembled at site. Our trackers are delivered in 6 to 7 parts. So it becomes very, very easy. There is no rejection at sites. It is all fit and finish. We do not propose any sensors on the systems. It is all based on the astronomical positioning system of the sun. So as long as you're able to fit in the GPS system, the trackers work precisely to the position of the sun. On the corrosion category adaptability, we can proudly say that not only C5, but even C5M, C5I, and C5 high, we are adapting our trackers to all these corrosion capabilities because of the coating technologies that we have introduced in the system. Uptime guarantees, comprehensive maintenance package of 25 years, and generation based guarantees are something that we discuss with the clients, and we can come to a conclusion on that. I'll show you a small video on trackers at this stage, which will be just to show. If you see the torque tube here, it is on the oscillating part. It is not a torque tube that is rotating around its axis. and there is no metal to metal contact. This torque tube is floating in the air. Now, because it is floating in the air, there is no obstruction to it, and there is no hindrance to any path, and that is the reason why the power consumption is negligible. Plus, there is no part that can really wear out. I'll skip this one because this is just a video of a plant, which is an aerial video of a tracker plant based in which is in Maharashtra. So on the design features, we have the ANSYS FES certified up to 47 meters per second, even 50. Backtracking features is a common factor for all the trackers. Installation cost is very low because it's very easy to install. Optimized bifacial performance is a very typical strength of our tracker. Adaptability to any PV module size. You can take any size right from 350 poly to 700 watt peak HJT or the new range of N type modules. The power consumption is very low. The maintenance cost is negligible. The trackers can be controlled independently, so terrain adaptability is there, and the complete SCADA or the monitoring systems are available along with the tracker as a free package. Auto store feature is linked with the wind and the grid failure conditions. That means under high wind and under grid failure conditions, the tracker automatically go to safe position, which is a very important aspect of any tracker. We have a case study from Rajasthan where we experienced winds of more than 120 kilometers per hour, but recorded 95 kilometers per hour at our site. And the trackers went to safe position very safely, and there was no issue. Not a single module was damaged, not a single tracker was damaged. It went into tracking right away. On the operation part, we have four normal modes of operation. One is a regular tracking, which is a normal. Wind mode is during the stow position. Snow mode is for the snow position where the trackers are all tilted in the extreme angles. And the cleaning mode is as you see on the picture on the left, where there is manual cleaning involved. You have this function where you can take one row at a time and you can clean both the sides of the trackers. Coro Protect is a very important aspect of our offering. Coro Protect is a technology that has been developed and adapted to the solar tracking systems by us. Uh, if you know, if we all realize that most of the tracking systems are coming with hot dip galvanized metals now. There are various disadvantages to this. One is it's a highly polluting process with acid fumes and molten metal management. The coatings are not even. The variation can be as high as 30%. As compared to that, the coatings that we have created is an aesthetic coating with a variation of less than 2%. Zinc contamination with ferrous and other metals is rampant in any local galvanizing process. There are no variations in the coating material as far as Coro Protect is concerned. White rust observations are prominent very easily and very quickly on the hot dip galvanized systems. White rust on our systems is not possible. The high coating thickness of 120 micron ends up with a salt spray test of about 1200 hours. Our coating thicknesses of up to 24 micron can deliver up to 3000 hours in salt spray tests. And the adaptability to corrosion or the corrosive atmosphere is obviously because of these tests that we have. In terms of ease of installation, I had mentioned that we are delivering only 7 or 8 paths. So pedestals is common. That's point number one. Point number two and three are the central bearing assemblies and the side bearing assemblies. These are completely pre-assembled prior to dispatch, and they are simply mounted on the pedestals, and then the torque tubes are fitted. At the torque tube level, that is point number four, the tracker is actually in operation without the electrical part. You fit the motors, you can the tracker is fully operational in terms of the complete controls and others, and in the end you can fit the purlins and the modules, which completes the tracker. Now with this installation, we have experienced that with 30 people at site in India, people are able to commission almost a megawatt of trackers a day. That's the reason why we say that it's a very easy tracker to install. Sometimes the field reports indicate that these trackers are easier to install than a fixed tilt system because of the work that we have done. I have already explained the sun tracking path that we follow the sun. So the tracking path on a mid June, which is our longest day, and the shortest day in December, are totally different in terms of tracking time because it is following the sun. A case study, again a prototype in Rajasthan, India, where we ended up generating about 59% extra generation on a particular day on plants which are at the side by side on a fixed tilt and the one operating with our tracker. That same plant at the end of the year generated about 32.72% increase over fixed tilt, which is in itself a very, very encouraging sign in terms of tracker performance and adaptability to various plants. This is all that we have about the tracker now, and we can take questions in case, or we can just take it forward now. Thank you.
Thank you so much, Mr. Agarwal, for that insightful presentation. We do have some questions here which people have posted and very keen to know about the trackers. I'll just present a couple of them here.
Yes. So, Nada Wasim, I can see the question here. Can we use robotic cleaners on this system? So the robotic cleaners will be used on the system where the panels are flat. For the tilted module panels, the robotic systems have not been adapted yet.
Okay, we have a couple of more questions.
Is single axis tracker more economical than fixed tilt? I would say yes. It depends on what exactly you're looking at. If you compare on a generation level, let's say that if you are looking at a 26% CUF, to achieve this 26% CUF, a tracker plant will be more economical in terms of capex on a per megawatt peak basis than the fixed tilt plant. If you look at the long term return basis, yes, you would spend something more on the capex overall in the tracker, but the return will give you more than 400% or 500% return on your, or the NPV is maybe 300% on this. So in either way, if you look at it from the capex perspective or from the return perspective, trackers do become more economical than the fixed tilt plants. Okay, so this is a very, very good question about the 10 to 15% generation gain from dual axis over single axis trackers justifies a 4x increase in the structural tonnage. Well, you see, the adaptability or the usage of dual axis trackers is very, very different from single axis trackers. Dual axis trackers are normally adapted in areas where what should I say, the sun inclination angles are, let's say, in places like Northern Europe or the mid Europe. The sun angles are extremely low during winters. That is where it is, and the generation details that I've given for a single axis tracker is adaptable to the areas where we are under operation in the Middle East and India and others. The same single axis trackers do not generate that high in those areas. Second point is the plants when they are very, very small. Let's say there are just a few trackers to be installed. Dual axis is the only choice because you do not get generation from the flat module single axis trackers in those areas. The cost wise also dual axis trackers do not justify the installation as in today, especially if you compare with the innovative designs of tilted module trackers that we are providing. So, differential, the payback periods are far more longer for a dual axis tracker than a single axis tracker. And this is one of the key reasons why the single axis trackers have been adapted or adopted by all the developers or most of the developers all over the world. And dual axis trackers, the adaptability or the adoptability is a little bit on the weaker side as of date.
Thank you so much, sir. So we're still receiving some questions. Hopefully, we can take that after the panel discussion. So before we move on to the much anticipated panel discussion, I would just briefly like to screen a few poll questions where we just would like to get to know our audience a bit better. So these poll questions will stay open till the end of this webinar. I would request our audience to kindly submit their votes for these polls, and these will stay open in the polls section till the end of the webinar. Thank you. We have a few more questions which are there. You can see it in our polls section. I would request the audience to kindly keep on voting till the end of the webinar. So we are moving ahead. Thank you for joining us as we explore how advanced solar trackers are revolutionizing utility scale projects in the Middle East. By enabling PV panels to follow the sun's path, these trackers significantly boost energy output while thriving in extreme heat, wind, and sandstorms. So, the session today will feature innovations in single axis and dual axis trackers, sustainable manufacturing, and their role in enhancing ROI and reducing LCOE. With leaders like New Energy driving scalable, eco friendly solutions, this webinar is essential for anyone shaping the region's solar future. Here I would like to make a small announcement. Attendees can post their questions in the Q&A box and our speakers will answer those questions at the end of the panel discussion. So without further ado, please allow me to introduce you to our esteemed panel of speakers for today. We have Mr. Jeffrey Bayer, founder and director, Zest Associates, Mr. Mohammad Omar, head of engineering ex-Noor, Mr. Brijesh Gupta, director and CEO, New Energy Renewable, Mr. Satindra Agarwal, MD, New Energy Renewable, and Mr. Javed Sheikh, associate manager of energy advisory from Sagar Energy. Mr. Jeffrey Bayer will be the moderator for the session today. Over to you, sir.
Thank you very much, Ala, and thank you very much, Satinder, for the fascinating presentation. My name again is Jeffrey Bayer. I'm the managing director of Zest Associates, a sustainability consultancy based in Dubai. I'm delighted to be moderating today's panel. I'm going to ask our speakers to introduce themselves one by one, and then we'll turn to some questions that we can run through together. Satinder Agarwal, thank you very much already. You've presented yourself and your presentation, so I'll move to your colleague Brajesh Gupta. Brajesh, would you like to say a few words? You're on mute there, Brajesh, sorry.
So sorry. So hi everybody, welcome to this session. I am Brijesh Gupta uh, and working in the renewable industry for last 10, 12 years now. And it's good to be associated with a product company now from earlier an IPP platform. Uh, we'll take this forward. So thanks, Jeffrey.
Thank you very much, Brajesh, for joining us. Over to you, Javad Sheikh.
Hi, good evening, everyone. I'm from Energy Advisory in Skr Energy. I am a technical advisor to IPPs in reaching a techno-economical solution for solar PV systems and storage systems. I have a background in systems engineering, and also recently I have helped and advised IPPs in recent REBDO rounds for Saudi, and I'm also advising a couple of C&I projects in the Middle East region, particularly oriented towards optimizing trackers. Thank you.
Thank you very much. Look forward to hearing from you more. And finally, over to you, Mohammed Omar, please. Mohammed, we can't hear you. You're off mute, but I'm sorry, I can't hear you right now.
Yes, can you hear me now?
Yes, perfect, Mohammed.
Yeah, sorry. Uh, Good afternoon, everybody. This is Muhammad Omar from Exnur. Actually, I'm the head of engineering and operation at Exnur, one of the new developers in the Middle East, especially in Saudi Arabia, UAE, Oman, and Bahrain. Uh, Exnor is a baby company between two huge companies, which is Exilio in Spain and Datco Group in Dubai. Um, Mainly focusing on the renewable energy projects in the commercial and industrial scale in the Gulf region. For myself, I am around 11 years of experience in the renewable energy sectors and electrical sectors. Uh, Worked before in major companies and major IPP developers. So that's me.
That's great. Thank you all for joining us. And actually, I'm going to start with you, Mohammed, for our first question. I mean, you've been looking at the business in the Middle East region. Can you just give us an overview of the rapid growth of solar energy in the Middle East region and the kind of opportunities that it's presenting here?
Yes, actually, there are many rumors and expectations. We can take what happened in WEFS in 2021. The renewable energy scale for the Middle East region, it was 2.1 gigawatt, and now we are talking about 9 gigawatt in just 2 years. And the expectations that we are going to reach to 61.1 gigawatt with GACR around 45.9%. Uh, so uh, so no, we have a big potential in the Middle East regarding the renewable energy. We are considered the second potential countries in the renewable energy market, especially in the market of Saudi Arabia, which is expecting to reach 58 gigawatt by 2030. So there are huge insights, huge rumors, especially if you found the signed PPAs that has been signed in 2024, especially the last one was 1.4 gigawatt with EDF between the Saudi company and EDF. There are the projects of RIBDO, RIBDO 1, RIBDO 2, RIBDO 3, and RIBDO 4. They are phases. Uh, so there are very high potential in the renewable energy in the Middle East. I would like also to talk about Egypt. Egypt is planning to reach to 42% of renewable energy feeding the national grid by 2030. UAE is also planning to have a 30% of the national grid energy. It will be from renewable energy. So, and Saudi Arabia is aiming to reach 50%. So, yes, they are converting from fuel to renewable energy.
Thank you very much, Mohammed. I mean, it's a very exciting time in the Middle East across all countries. I know with the boom of green hydrogen production in Oman as well,
Yes,
having the third
yes.
round of tenders from Hydrome, many gigawatts. I think 16 or 18 gigawatts already tendered, and another dozen or so to come. And in Saudi Arabia, I'm actually currently working as the chief technical advisor to the Ministry of Energy through the United Nations Development Program in Saudi Arabia. And they're forecasting 100 to 130 gigawatts of renewables, both solar and wind, by 2030, with about 20 gigawatts in the pipeline every year. So, as you said, hugely exciting time with massive growth
Hmm.
potential. Um,
Exactly.
and I want to ask also, Jawad, if I can turn to you. I mean, the Middle East does present some particular challenges when it comes to solar. We have uh, we have strong heat, extreme heat, sandstorms, high winds, all of these things that are not the best for panels. So tell us a bit about how those types of environmental challenges can be addressed in the Middle East.
Sure, and I would like to give a categorical answer to that question pertaining to various KPIs, or I would say key driving factors or key driving environmental factors for tracker design in a multi-megawatt utility scale plant. First one being, of course, the elephant in the room, which is wind. Um, so when it comes to wind, a plethora of items can be looked at. Particularly, if I was to give you a categorical answer within wind, so there are two main aspects that are to be considered. First aspect is basically a static gust wind speed aspect. which has to be curated from nearest stations, and a 3-second maximum gust wind speed has to be considered while designing a proper stable tracking system. Furthermore, this very often dynamic aspects, or to give you very technical, terminology, aeroelastic instability is one of the key aspects in designing uh, tracking systems, particularly in Middle East, because while we only have a precedent set majorly oriented and skewed towards only using static bits of designing trackers, aeroelastic instability is turning out to be a real differentiator between high speed regions wherein we are seeing Repto projects coming in, wherein all the Repto projects that have come in the latest round in R5 have a gust wind speed of higher than 45 meter per second. So both static and dynamic aspects of wind structure design, or rather tracking system design, is quintessential. Second bit is flood risk. You could see a lot of flood risks coming in key Saudi regions, primarily Makkah, Medina, Jeddah. So earlier Ebdo rounds, if you recollect, R2 was in Medina, and a couple of sites for CNIs are also near Jeddah. And flash flood is something which is changing the geography quite a bit in that region. So doing a comprehensive flood risk assessment is quite important. Why? Because this will indirectly affect tracker designs at a particular place. So for example, if you run a flood risk assessment for a demarcated boundary, you may find a lot of these regions within a single plant layout boundary may have different flood risks or different flood depths. So a certain area may be applicable for a height of structures for zero point 0.5 meters, wherein some portions of the same boundary may end up in a higher flood risk, and you have to end up installing higher or heighted tracking systems. And when it comes to sand, and higher wind speeds may cause sand accumulation in a lot of these tracking systems. So the top part of tracking system is usually handled by robotic cleaning systems. But if you go into nitty gritty such as top tube actuating systems and dampening systems, these have to be IP rated as required. And these can also be site specifically, I would say, manufactured in such a way that you provide enclosures at suitable area to avoid dust accumulation. And a traditional way to be just people always do manual cleaning. So for dust accumulation, you can go with blowing the sand for the bottom surfaces. Similarly, on corrosion level, you could see there should be a scientific approach towards categorizing or selecting a corrosion category for module mounting system. That scientific approach can be from looking at severe events coming in from NASA's databases, MODIS's databases on key aspects such as sulfate, chloride, humidity. These 3-4 KPIs help us identify and use a scientific approach towards categorizing corrosion category while selecting and designing tracker systems.
That's very interesting. Thank you, Jawad. And one more question, actually, to follow up on that. When it comes to sandstorms, I know this is one of the big risks that is foreseen, especially as we get to a high penetration of renewable energy in the region. If there is a sandstorm, it can knock out, tens of gigawatts of production, which can lead to brownouts or blackouts. It's a big risk in terms of energy security. Do tracking systems help to avoid that type of eventuality should there be a sandstorm?
So there are two components to it, like I discussed, Jeffrey. The first part is settling of sand and dust particles on the tracking system, on the top surface of tracking system. So this does not really affect the stability of the system itself. Uh, it will not really blow away because we are sizing it based on two things. We're sizing it based on worst case gust wind speed conditions. So the risk of blowing away is the kind of mitigated. However, settling of dust particles or sand itself will not really affect the stability, like I mentioned, of tracking systems. However, in certain cases wherein there's proven precedence of sandstorms through some records available in the nearby databases, we could have a retrofit solution for a specific plant in which we protect dampening system, actuating systems, sleeve drive systems. So that would be a good way to mitigate that risk. And like I mentioned, data is something which is a driving factor in designing such systems. So coupling records which is based on nearby stations as well as satellite imageries is a good start. So you could see that across a certain time interval, the pixel changes according to what you see as a part of change in elevation, change in pixel color. So both of these approaches should be coupled in a way to benchmark those those parameters that drive tracker design.
Thank you very much. That's very interesting. And actually, Brajesh, I want to turn to you as well. We heard from Satinder's presentation at the beginning about how single-axis and dual-axis trackers optimize energy output by adjusting to the sun's orientation. Is there anything else you want to add in terms of how solar trackers mitigate climate challenges?
Yep, I think that's a very interesting question, Jeffrey. So, if we look at specific generation, the solar modules have a particular efficiency. So, if you take 1 megawatt of DC module, let's say if it gives a 19% generation, okay, with solar tracker, you can extract higher generation, and we have seen that it can be 20%, 26%. So what happens is, from the same system, by putting tracker, you can get extra generation. That means if somebody has a power need, energy need, rather I'll call energy need of an X amount. So instead of going for a fixed tilt with a higher DC capacity, they can go with a lower DC capacity with tracker. And anything that you use less contributes to the net zero, the recycling, the e-waste generated, and a lot of things. So you use less raw material. Going back, you can go back up to the mining site. But yes, and that's where the sustainability, ESG, and the new concept of net zero comes in. So I think anything that can reduce your consumption here in terms of reducing your the entire capacity for the same generation, that can be really helpful on that point.
And Brajesh, one of the things that interests me also in this, when I saw the graph that Satinder put on the screen during his presentation, where you extend the shoulders of the day, right? So instead of a steep bell curve, you get a much wider curve. There's implications in terms of grid operations as well, right? If you're able to provide max power or almost peak power for a much longer part of the day, you don't need to include these types of balancing mechanisms when it comes to operating the grid. Have you seen an interest from energy system operators, national grids in the tracker system because of their ability to prolong the day, so to speak, of solar power generation?
Yeah. So if we look at it, the main challenge of renewable power, whether it is solar or wind, for that matter, has been the inconsistency. So when there is a demand for power, at that time the power is not available, and as we know, neither the power cannot be stored. So you just, now the battery energy storage are coming, but again, they have their own challenges. But yes, they going forward, they are going to be there. So if we are able to provide a very stable power for a longer period of time, the it helps. So if you look at it in US market, the North America market, maximum projects are on tracker. In Europe, more than 70% projects are on tracker. And going forward, in India, the lot of large scale projects, more which are more supported by government of the government central agencies, they are now trying to push and make the tracker compulsory as part of their tender. because they are also seeing the benefit of this broader shoulder or a more stable power generation.
Very interesting. Thank you, Brajesh. Satinder, I want to come back to you and also go back to a question around hot sand accumulation. We heard in your presentation about the kind of lack of metal on metal in your trackers, the lack of plastic parts. It's great. It means there's reliability is significantly improved. Um, can you help us understand the detrimental effects of hot sand buildup on tracker mechanisms and panel performance? How does hot sand play a role? Because it's nice today in Dubai, but it sure gets hot in the summertime. Tell me.
There are two aspects as what I understand. One is the sand itself, irrespective of the temperature, and one is the sand which is very hot. Now, let's look at the sand at the normal temperature first. A regular sand that is blowing, there are two impacts on any solar system. One is the sand, the fine dust is accumulating on the solar modules, and this basically affects the generation of the modules in terms of percolation of light onto the cells. Now, this needs to be cleaned very regular. On the tracker part, the bigger impact is that sand accumulates on the bearings. When you have rubber or darolene or nylon bushes or bearings, the sand, along with the sudden shift of temperature in the night, which causes dew formation, the sand accumulates on that, it gets tough and it gets rigid and it forms a big obstruction to the movement of the or the free movement of the tracker. Now, this is one of the major, I would say, the causes of concern for the long term dependable operation of the trackers. Now, our design basically is eliminating the use of bearings, the use of the rubber bearings, by adapting to a system which is basically oscillating in free air. Now, as I showed the video, the normal trackers which employ rubber bushes or bearings, the trackers or the torque tube is rotating on its own axis. In our case, it is rotating in the form of a pendulum or a oscillating one, where there is no hindrance or there is no metal to metal contact. As much as sand can accumulate on these trackers, as far as the mechanical movement is concerned, it is not affected, by any extent. So that is one of the aspects that we have taken care of. Now, coming to the hot part of the sand, especially when the sand is blowing at a reasonable speed, in the air, and there is a wind associated with hot sand, it has got a corrosive effect. Whether it is the modules, it can also affect the glass of the modules by the impact, and it can, of course, affect the coating of the trackers or the finishing of the metals, eventually leading to faster corrosion. Now, these are the two impacts on our part. There are two developments that we have done. One is a development that has already been done, and the second one is under final stages. The first one, as I've explained the Coro Protect technology. So in the Coro Protect technology, we have various types of coatings. We can have a very very strong Teflon coating, which can adapt to even the hottest of sand, and it will not get corroded. Like Mr. Jawad very, very rightly said, it's the data. The input data has to dominate the design of the trackers. Now, once when I was hearing Mr. Jawad, it was really insightful when we hear, that okay, we know that okay, hot sand is going to blow. The coatings of the trackers, the coating or the selection of the material can be adapted to that. But yes, these are the impacts of the sand that affects the long term operation of the trackers in terms of generation and dependability both.
Uh,
Jeffrey?
Thank you very much. And can you just explain a little bit more, just for myself and for the audience, about the floating nature? When you showed the video, it looks like there's pistons moving the. Is that how it's working, or can you
No, no,
describe the mechanical? How does this?
no.
What? How do you
I
even
can,
float in
no,
the
no.
air?
Those are basically hydraulic dampers to nullify the effect of aeroelasticity or the
Okay.
aeroelastic flutter. So they are basically damping the aeroelastic flutter to make the travel more suitable under wind conditions. Otherwise, if I remove those hydraulic dampers, then there will be a flutter as you see in a typical wing of a plane when it's under high motion or something. The trackers are driven by the central actuator which is on the central pedestal, and that is how it's operating. Now, what we have done is we have used SS bearings on which these torque tubes are suspended. So the torque tubes are moving in a oscillating fashion like a pendulum as against rotating on its own axis. Now that is a technology by which, or the you can say the technique by which we have eliminated the usage of any non-metal bearings on the trackers. So
Very
it is
interesting.
suspended. It is suspended from the top.
Understood. Understood. Thank you very much for that clarification. It's fascinating technology. Brajesh, I want to come back to you actually, and just to learn a little bit more about New Energy's sustainability practices when it comes to manufacturing. Satinder mentioned you have 2 gigawatts annual capacity, massive scale up this year. That's very exciting. Tell us a little bit about the environmentally friendly manufacturing practices that New Energy utilizes.
So, the manufacturing facilities that we are all our tracker designs are such that we reduce and minimize the waste. Basically, even for the way we have designed our parts, we try to maximize the use of the steel parts that are going into it. Uh, we are also trying to source very near from where we are located, reducing the logistics burden to a large extent. Uh, we are moving with our own expansion plans, which will bring in the just-in-time kind of concept, and just-in-time will help us further help on the you can always go more sustainable on that.
Thank you very much. Those are important components. Um, Mohammed, I want to turn to you quickly as well to ask about scalability. So we talked at the beginning about the massive ramp up of installations that's forecast in the Middle East with a few country highlights. Um, how do you see that demand for production, for installed capacity, aligning with the forecast demand for trackers themselves for utility scale projects?
Um, Actually, I would like to say the third thing is the modular design. The modular design will play an effective role in the extension of the solar panels, of the solar PV parks, and all that stuff. It's very important to have a modular design for the trackers and all the equipment together. The second point I would like to is advanced manufacturing techniques, especially in the automation and the communication technologies between the trackers and the monitoring systems. Uh, Also, the R&D is very very important to reach to the scalable targets.
Thank you very much. Jawad, do you have anything to add to that in terms of meeting the scalability needs for the Middle East's demands for trackers?
I think this was well captured by Omar. Uh, I think there'll be plenty of opportunities considering the rising scale of capacities that are coming into the picture. So if you see Repdo 1, 2 started with 50 megawatt, 100 megawatt. So I was a part of Repdo 2 as well. This is back in early 2020, 2021, wherein the capacities were 20 megawatt, 50 megawatt. Now these have been multiplied by X into 10, wherein you could see recently IPPs have signed a PPA of 1.4 gigawatt, 2 gigawatt.
Mhm.
So now the
Yes.
discussions will be in terms of gigawatt. So I think it would be good to see, and the future is interesting.
Thank you very much. I'm going to just move to our final set of questions here around the future of tracker technology in the Middle East solar market. Mohammed, we talked a little bit about an overview. Where do you see market trends and advancements in tracker technology really specifically tailored for extreme climates? How do you see that progressing?
For the future, I believe that we can use more low carbon materials. Also, we can increase the energy efficient manufacturing. Also, the usage of the recycling, it will be very very useful. Um, Also, I would like to talk about minimizing the wastes from and as engineer Standard has mentioned, decreasing the number of parts for the trackers, it will be very very useful. Uh, Also, making it easier to install and easier of maintenance, it will be very very useful. Also, I would like to talk about the water conservation using a closed loop water cycles. It's very very it will be very very helpful.
Thank you very much. Satinder, I'm going to turn to you as well. In terms of market trends and advancements in tracker technology, I mean, clearly you're scaling up your production capacity enormously from 2 gigawatts way up there to almost, did you say 10 gigawatts a year? Amazing growth. So you clearly see some very promising market trends. Where do you see things going this year, next year, out to 2030 for new energy and for the tracker sector as a whole?
Okay, so we have actually started offering these trackers at a very small stage, at a very small scale. I would say, starting in 2021-22. We have gone through the process of adapting to the site conditions. We have seen the performance of the trackers. We have gone through the challenges that we faced at various sites, and then that is when we have started scaling from 300 megawatts a year to 2 gigawatts a year in the last 4 months. And the way the tracker market is growing, we believe that even 10 gigawatts a year in the next 18 months should be something that will put us to the next pedestal of growth. It does not be the end of it. With the type of numbers that we hear, even from India, India is targeting 500 gigawatts by 2030. You talk about Middle East, you talk about the US, the European markets, the Eastern European markets. We see multi gigawatts coming in from very small countries also. So there is going to be a huge demand. The tilt from fixed tilt technology to tracker is visible in many ways. There was a time when we saw that the tracker adaptation would be linked to the module prices, but we don't see that anymore, especially when you look at the CNI clients. They say we want the generation between 9 and 12 in the morning and between 4 and 6 in the evening. So that is when again tracker comes in. We are finding that battery energy storage solutions are being adapted practically on every renewable energy project to give them 24 by 7 power. Now, a inverted bell curve is not adaptable to charging the battery. You require longer periods of stable, or I would say equal amplitude of energy to charge the batteries effectively. All of these factors are going to contribute to the adaptation of trackers in all the plants that we see. In India, also from a very, very low level to currently at about 20 to 25% of the plants being put with trackers is a very, very encouraging sign.
That's very interesting because you're right. I think historically, at least I've thought that the cost of modules, as the cost of modules goes down, the the need for trackers goes down because the actual PV itself is so cheap. It doesn't matter if it's flat or tracking. But you're saying that's not the case, and I think that's very interesting development. Is the and you've given a couple of reasons: battery storage and the need for this longer shoulder commercial industrial clients requiring early day and late afternoon sun. So do you see trackers really dramatically improving the return on investment and supporting the renewable energy targets
Yes,
that are quite extreme in the region? Tell us a final word, maybe.
yes. I personally do see trackers being adapted more and more in all the renewable energy projects. One of the reasons also is that irrespective of the module price, if the module price goes down, your levelized cost of energy goes down. But with the tracker, it is always lower than the fixed tilt LCOE. Now there are considerations of adaptation of tracker. At one point you may see, compared to the fixed tilt system, it may look a little bit more expensive on a unit basis, but on the generation basis you are actually saving 6 to 7% of the cost on the initial capex level itself. As far as the technology is concerned, yes, the technology will be focused more and more to counter a few factors. Like one of them is to counter the atmospheric challenges like corrosion, wind, as Jawad has very rightly put in. The second part is sustainable production. In our case, our Coro Protect technology is absolutely sustainable and non-polluting as compared to the hot dip galvanizing process that is currently in adaptation with most of the metal protection. That is one. Reducing the weight, getting it more efficient. We are not saying reducing the weight only for the economy, but reducing the weight by engineering standards also gives you a sustainable impact. And increase of generation. The use of natural resources is the best when you're using the similar, I would say, similar values or similar consumption of material, and you're giving better generation out. Though it may be tangible or a little bit intangible gains, but all of these basically contribute to the sustainable aspect of manufacturing and getting more and more into the renewable mold.
Gentlemen, this is absolutely fascinating, and I want to thank you each individually for your contributions. Satinder Agarwal, Brajesh Gupta, Javad Sheikh, and Mohammed Omar. Thank you again. My name is Jeffrey Byard. It's been a pleasure to moderate with you. I'm going to hand back to Ala Khan to take it over from here with any audience questions. Thank you very
Thank you,
much.
Jeffrey. Thank you, Jeffrey.
Thank you, Jeffrey. Thank you so much.
Thank you, sir.
Thank you.
Thank you so much, Mr. Bayer, and to our esteemed panelists for that wonderfully insightful session. We have a great overpour of questions. People are curious to know more about trackers, so I'll be screening them here on stage now. So, at what cost of electricity a tracker becomes viable? As we know, higher the electricity prices, better will be the return.
Yeah, I, so uh, the answer is in the question itself. To be honest, so Abhinav, you have to work out your financial model. We always help people with the layout and the cost of the trackers, but yes, in the long run, your LCOE will be much better with the trackers. And electricity cost, it all depends on region to region.
Just to add on to Brijeshji's point on the tracker costing and selectivity of trackers, it's driven by weather patterns also. So in the region where the discussion is all about, the Middle East, which is rich in two things. It's rich in albedo and it's rich in DNI and DHI, which will end up in a head and shoulder difference in tariffs and the cost of electricity between fixed rate and HSAT systems. Thank you.
Thank you.
Thanks, Javed.
So on this one, how many panels one tracker can rotate? So Abhinav, there are multiple tracker manufacturers giving different designs. As far as we are concerned, we try and restrict our tracker length to 110 meters. A typical 540 or a 580, 590 watt peak module, we would say we would accommodate up to 90 modules. So what components needs to be particularly strengthened? Of course, I would say the overall tracker design has to be strengthened, which includes the pedestals, which is very important. Torque tubes is the next because they give the strength to the aeroelastic stability. Purlins on which the modules are mounted. These are the three main components which will be on focus when you talk of higher maximum wind speeds. Of course, again, it also depends on within the max wind speeds, what is the gust wind that is the specified, and all these factors also make a difference on what the components are normally strengthened. More than the components itself, it's the layout that needs to be designed properly. Whatever may be the wind speed, the concept of external trackers and the internal trackers is a very critical part of making the solar plant extremely viable under the high wind speed specifications. The external trackers, when you talk of external trackers, they can be extremely strong as far as the comparative to the internal trackers are concerned. So you are basically making one person or one set of equipment much more stronger to protect the other component, other equipment which can be a regular normal designs. So it's not a particular part or it's not a particular component. I would say it's the overall design of the plant, which should be in your in the overview when you design a system to wither or to sustain high wind speeds. What are the changes?
What are the changes will be required for sandy soil? So, it's only the change that will be required in the foundation design, depending on soil investigation, and the consultants can, after getting the soil studies, they can provide the designs for that. Basically. Yeah,
The
Sachin.
accuracy of the tracker as per sun path during summer and winter season, as you have seen in my presentation, we are following the concept of astronomical positioning system, which is tracking the sun precisely on a daily basis, on an hourly basis, and on all throughout the year. So the accuracy, as far as theory is concerned, I would say is 0.001 degrees. In terms of practical accuracy that we achieve, depending on the variables or the installation errors or something, we would say it is still accurate to less than 1 degree. The cost per watt of our tracker is variable depending on the specifications, depending on the type of module that you use, depending on the series connections, depending on the corrosion category, depending on the layout, depending on so many factors. So once we have a proper location and we have the modules to be installed or to be used by the project and the layout of the plant, that is when the cost per watt can be derived.
So this question is directed to Mr. Omar. What are your views on AUH market, Mr. Omar?
Um, from which perspective? I didn't get the question, to be honest. From which perspective? What are the views of AUH market?
Okay. So we'll move on to the next question then.
Yes, please.
I believe these are not very.
Now, okay, so I can give you a quick answer on this one. How much does it impact the capex cost? Like I said, depending on the type of module that you use and the depending on the type of design that you use, the capex cost, if you look at it on a per megawatt peak basis, may increase by about anywhere between 10 to 11% on the current module prices, and the generation increases about 23 to 27%. And on the generation part, if you set a goal that I want to generate 24% CUF, then the reduction of capex cost is on the similar lines of about 8 to 10%. One, one,
Yes. Yeah.
one word answer, yes. Yes, we offer comprehensive AMC under specified conditions. The normal warranties that we offer on the electronics and motors is 5 years, special case 10 years. On the manufacturing defect warranties, it's 25 years. And on the mechanical parts, it's 10 years. So when you are installing a plant as compared to the fixed tilt, a tracker is helping you generate the same amount of energy using much lesser, almost 25% lesser modules. So when you have lesser modules, you have much lesser burden on the responsibility of e-waste or module recycling. That is the main contribution of tracker, because you are able to generate much higher values of energy with the same capacity of the plant using a tracker. Yes, as I mentioned, as I have detailed in my presentation, the we have worked very hard to standardize on the complete tracking system that we have. We are pre-assembling all the critical parts and sending it to the site. As compared to the fixed tilt, the question here is, how can we cut down additional construction time that would be necessary to install a plant? I would say that with our tracker, I can make it lesser than the fixed tilt plant. The tracking systems can be installed at faster rates.
Thank you so much, sir. I believe that's the last of the questions we have received. It has been an insightful session. Thank you, audience and panelists. With this, we have come to the end of our virtual event. And a very special thanks to Mr. Bayer for superbly managing the session. A big shout out to our attendees for extending the valuable time, and a special thanks to New Energy Renewable for their immense support to organize this event. Before we close, I would like to give the floor to Mr. Brijesh and Mr. Satinder if you have any closing remarks.
No, we are exhibiting our trackers at the WFES, and we invite everyone to come and have a look. So we have a working prototype model that will be in exhibition there, where you can see all this suspended pendulum design and other good features of the tracker. We invite all of you, and we thank everyone for joining us in this wonderful session. Thank you very much.
On my part, I would also like to extend the same invitation to everyone here, that they can come and actually witness the tracker, the way it is designed, and it's a full functional model that we will have. You can experience all the parts and how these trackers are so much more adaptable to the challenges that we face in the Middle East, like sand and dew and the associated problems. This will be there at there, and that's all that I have to say. And I have to thank everyone for giving their time. Mr. Bayer, Jawad, Umar, Ala, thank you very much. We thank you everyone for spending this time with us today and giving us this opportunity to present ourselves.
Yeah, me too. I would like to thank you all so much for this fruitful, comprehensive webinar and panel discussion. Uh, Also, I'm very glad to know about new energy and their capabilities and their all stuff that they have that you are mentioned. It was very very useful for me. Thank you so much all. Thank you so much for the audience, and thank you so much, Mr. Jeffrey and Allah. Thank you all. Of course, Jawad.
Thank
Thanks.
you. Goodbye,
Thank you.
all.
Uh,
Goodbye.
Thank you.
Jeffrey, thanks a lot for wonderful moderating it. Thank you.
My pleasure. Anytime. Thank you very much.
Thank
Take
you.
Thank
care.
you so much, all. Thank you.
Thank
See
you.
you everyone at WFES. Thank you.
We look forward.
Thank you.
Thank
Yeah.
you.
Bye bye.
Bye.